Cloud Formation
by
Bella and Veronica.
Adiabatic process. So what is the adiabatic process? Well, the adiabatic process is basically a process in which the system experiences internal energy changes due to work, but no actual transfer of energy or mass takes place between the system and the surrounding environment. In simple terms, adiabatic process is just a change in energy without a transfer of energy. This could be because of an insulated environment or the process happening very quickly, which is the case with cloud formation and cooling and lifting. Most clouds form through adiabatic cooling. As air parcels move upward in the atmosphere in an action called lifting, the parcel will expand due to pressure decrease, and its temperatures will also decrease. The parcel won't be affected by outside temperatures because expansion is so rapid. As the parcel keeps lifting in the atmosphere, it will eventually reach saturation, and therefore condensation will take place after. The dry adiabatic lapse rate is the rate at which the temperature decreases due to adiabatic lifting and expansion. This rate is only applied to the air inside the parcel. Because there is no exchange of heat as the parcel rises, it gets colder than the air surrounding it. The moist adiabatic lapse rate is the rate at which the temperature of a parcel of saturated air decreases as the parcel is lifted up into the atmosphere. A dry adiabatic temperature profile will have lapse rates near 9.8 Celsius per kilometer. The moist adiabatic lapse rate is near 6 Celsius per kilometer. The difference in the two is determined by water vapor, hence the names. Orographic lifting occurs when air runs into a mountain or any raised land and is forced to go over the mountain. Orographic lift is responsible for a few things, like the snow caps on top of mountains, and it is also responsible for the high precipitation over elevated land.
When convergence is mentioned in relation to clouds, it is talking about when air flows from different directions and meets in the middle. When this occurs, it is more likely for the air to change direction rather than change density. When convergence occurs at ground level, the only place for all of the merging wind directions to go is up. This can result in adiabatic cooling along with cloud formation and possible precipitation. This can also happen when the wind slows down while keeping a higher speed upstream. This can happen when the wind is flowing over bodies of water, then suddenly flow over land. The land has more friction, causing the wind to slow abruptly, while the water causes the wind to flow faster. When this occurs, the wind essentially piles up on itself, pushing the wind at higher speeds upwards. In this scenario, condensation may occur as well as cloud formation if saturation is reached due to adiabatic cooling. Generally, cold air masses tend to sink and wedge under warm air masses. This causes the warm air to rise, condensation to occur, and clouds to form. Because the rising of the warm air is relatively abrupt, cumulus clouds tend to form, especially if the atmosphere in front of the cold front is unstable. When a warm air mass advances against a cold air mass, however, it slips upward and over the cold air mass. This is called overrunning. As usual, clouds form once saturation is reached. However, because this process is more gentle, stratus clouds form instead. Stable air, for example, would be when an air parcel would return to where they came from. Occurrences such as subsidence warming tends to make the atmosphere more stable. Unstable air, in comparison, would be when an air parcel does not return to where it came from. Many factors can make the air unstable, such as large-scale lifting and cooling aloft. The stability of the atmosphere is determined by the particular tilt of the environmental temperature profile and the environmental lapse rate. In a warmer environment, a parcel may rise, showing an unstable result. If the environmental lapse rate in the
Or not any other boo effect.
If the environmental lapse rate and the environmental temperature profile are exactly aligned, it may result in neutrally stable conditions. Cloud formation always occurs when saturation is at 100%. The lifting condensation level is where the cloud base is realized. Cumulus clouds usually sit lower in the sky and have a very fluffy and full appearance. Also, cumulus clouds sit slightly higher in the atmosphere and have the appearance of smaller puffy clouds formulated in rows in a broad area. Cirrocumulus clouds are even more sparse and sometimes have a rippled appearance. These clouds can indicate fair weather in the next coming days. Altostratus and nimbostratus clouds usually indicate rain or snow. Cumulonimbus clouds are very large and raise very high into the sky. These clouds can be a sign that hail, storms, or tornadoes may occur shortly.
Thank you for watching our video. Yay! Please give us an A.